We'll now look at linear versus exponential functions. So in general, linear functions represent a constant increase or decrease. And this is why we get a straight line, because for every equal change in x, so say x is increasing by 2's, we will see the same increase in y. Perhaps y is increasing by 1. There we go, because I know how to add. Perfect. And this gives us that straight line appearance. Recall, though, that exponentials involve repeated multiplication, which is why we get a curved line with exponential functions. And exponentials can either curve up or they can curve down. The reason we see these patterns is because linear functions involve repeated addition or subtraction, which is why we end up with multiplication, as we see in y equals mx plus b, where m, which represents the slope, is the value we are repeatedly adding or subtracting, and x is the number of times that we add or subtract it. We can compare this to our exponential equation, where y equals our initial value times the base, or the growth factor, to the exponent, where g is the number we repeatedly multiply by, and x is the number of times we multiply. So we see some similarities between the two. In both of them, x represents how many times we go through the repeated action, but in the linear, m is the value we repeatedly add by, and in the exponential, g is the number we repeatedly multiply by. Let's look at some examples. Example 3. Jessie is climbing up a 100-foot cliff. She climbs 2 feet every second. Define a function that gives Jessie's height above the ground in terms of how many seconds have passed. Okay, because Jessie climbs 100 feet, or 2 feet every second, she was repeatedly adding 2 feet to her height. This is a constant increase of 2 feet per second. For a function, Jessie's height is given in terms of time in seconds. So h represents Jessie's height above the ground. In feet, and t is time since Jessie started climbing in seconds. Alright, Jessie starts at 0 feet and she's adding 2 feet every second. So our final function is h equals 2, and this should be a t, 2t. H, which equals f of t, equals 2t. We want the domain and the range for this problem now. Recall, domain is the input, so in this case it's the time that has passed. And range is the output, and that's Jessie's height above the ground. The range is easier to do first in this problem, since we know Jessie is going to be anywhere from 0, less than or equal to her height, less than or equal to 100. And in interval notation, this is square bracket 0, comma 100, square bracket. We can then realize that at time 0, Jessie's at 0. This is less than or equal to t, which is less than or equal to however long it takes Jessie to reach 100 feet, which ends up being 50 seconds. And in interval notation, we get this.